Well, good evening, everyone. It's another Sunday, and you know that Sunday is problem solving day. So Sunday is a tutorial, is a problem solving session. Solving problems for which we did the instructional class already, or if there's no accompanying instructional class, like for simplifying expressions and so on, we'll have that on a Sunday. Transposition of formulae. Is the first one today, and maybe we'll do solution of linear equations. Factorization was done last Sunday. Some individuals want us to take a look at factorization again. You know that we have gone through the whole thing with factorization. Your basic factorization, taking a common factor, and that's the end of it. We have done difference of two squares, factorization by grouping. After factorization by grouping, what did we do? Maybe the perfect square. I think we did the difference of two squares and the perfect square after factorization by grouping. Then we moved to trinomials and trinomials in its simplest form. Then we went on to one that is a little bit more challenging. Then, of course, last week, Sunday, was an entire examination, factorization. Sometimes they are combined, the difference of two squares combined with simple factorization, and sometimes the trinomial is combined. Sometimes you're asked to simplify an expression. That means you're required to factorize both numerator and denominator. That's quite a bit. That's better. Yeah, so that's quite a bit that we did with factorization last week. I think that I took a halt on loading up the factorization audiovisuals. If you have a particular expression for me to factorize, let me do that now, because in a few we will go straight to transposition of formulae. And I have my old manual. You know that I prefer my old manual. So I have my old manual right here. And my internet feed seems to be at a lower speed. I hope that's not affecting you at the moment, because I can see digitized movement instead of a smooth movement on the screen. Let's see. Matrices, vectors, matrices, and transformation is the last. Yes, I'm going to do that, but vectors, matrices, and transformation, that's the last, what do you call it, module that we're going to do. I'm going to do matrices, yes. Joanna James, you're the, oh, Yvonne. Oh, Yvonne. That's excellent. Right, so some individuals were asking me to do more factorization. And I'm not so sure. I think that you probably go all the way to the factorization of a trinomial. And when I say the factorization of a trinomial, I mean the last one. The one whose coefficient of the square term is not equal to 1. So I'm thinking that's the kind of factorization of trinomial that you'd want me to do. So if you have a particular trinomial or whatever there is that you need me to factorize, let me just do it right now. As I said before, especially for those students who are joining in for the first time, or if it's not even the first time, but right, but if it's not even the first time, but you're new, the Sunday session is a problem solving session. And in this session, I'll be solving problems for which we have done the instructional class already. So I need to know who wanted me to do the factorization. trinomial. Okay. What do we do then? We may move merrily if there is no one who said that we should do the factorization. Then you know that we have quite a bit ahead of us this evening as it pertains to transposition. And of course, transposition is the key in solving equations. And if you look at mathematics from the right perspective, you'll realize that a greater percentage, more than 50% of mathematics would be transposition, because you will have some question or the other that requires you to solve a problem, solve an equation. Usually when they give you what we call it now, an applied problem, or what we call a word problem, most of the times it turns out to be an equation. And when you are doing your vectors, your matrices, your transformation, your functions, you'll have equations. When you are doing the functions and you have to find the inverse of a function, you have to transpose. So transposition is the greatest, and I dare say that transposition is plagued with misconceptions. And two of the misconceptions is that something goes over the equal sign and changes sign. Well, that is one. And that you do something and you do it on one side. That's another. So whatever you do to change the value of one side has to be done to the other side in order to change the value in the same way, even if the intermediate step is not shown. Okay, let's go to our old, you use your new instructional manual, the one that you have. I have the old, because it's flexible. So that is why I'm always using an old manual. Here we go. And I think that we have about 20 of them. Now, I'm going to be doing, in this earlier stage, more explanation than action. And later on, I'll do more action than explanation. Let's go. Number one, S is equal to pi dn. And we are transposing, making n the subject of the formula. N is the proposed subject. It is accompanied by pi and d on that right hand side. And of course, pi dn means pi times d times n. So all of those are in a multiplication relationship. In order to eliminate pi d, therefore, since they are in a multiplication relationship, we need to divide. So we need to divide the right hand side by pi d in order to eliminate pi d. When we divide the right hand side by pi d and pi d is eliminated, we just have n. We need to do the same thing on the left hand side also. We also need to divide the left hand side by pi d in order that the equation will be balanced. As a result, we have s over pi d is equal to n. And it is not sufficient to have that n on the right hand side. As we said before, the equal sign is not a two-sided sign. So if you say x is equal to 3, of course you have equality there. And if you have 3 is equal to x, you also have equality there. But because of the meaning of this equal sign, this one is more of an intermediate step than a final answer. Because you are saying whatever x is equal to 3 is equal to it. In this case, you are saying whatever let's go back to this one. You are saying that whatever x is, 3 is equal to it. And here you are saying the value of x is 3. Of course, the value of x may be equal to 3. But in this particular case, you are taking it for granted that x can only have a single value. So this one is a more complicated or sophisticated expression than you are looking at. Because the equal sign is not a two-sided sign. There's a two-sided sign, and it is this one. Let me write. There's a two-sided sign, and it is this one. And you can safely say that what? A plus b all squared, some of you will remember this, is equal to a squared plus 2ab plus b squared. That's right. So this is saying that this is identically equal to this. And of course, you can safely say that the other way around is also true. Either direction, either this or this. Let's put it like that. So this is equal to this. Then you can say a plus b all squared is equal to this. You can turn it around any way and it has the same meaning because they are identically equal. But in the case of x is equal to 3 and 3 is equal to x, what you're saying here is that x has a value of 3. Now you're saying 3 has a value of x, which means where you're saying now that whatever the value of x is, 3 is equal to it. Now if x does not have a fixed value, then this one is problematic. So at this early stage, if you do not understand the finer details of it, you should at least understand that the equal sign is not a two-sided sign. And therefore, when you write this, when you're transposing a formula,